Good morning, everyone. First of all, I want to say thanks to Professor Yip with his very warm invitation. It's my great honor to be here to introduce some information about the Chang'se-5 mission and the scientific opportunities once the sample returned. Okay, the background I used in my PPT is the picture took by Chang'e-4 lander. The track was made by the U-2, the second lunar rover. It is still walking on the surface of the moon within the von Karman corridor. My talk will actually include two parts. One is about the mission schedule, and then I want to introduce how important is the sample and what we can might from the study of the sample. Here is the general frame about the Chang'e-5. From the left, you can see here is the launch vehicle. We call it Long March 5. This is the heavy launch vehicle, and the Chang'e-5 was launched in early morning of November 24th at the Wenchang Spacecraft Launch Center in Hainan Island. And this mission included is the most complex spacecraft compared with the previous Chang'e-1 to Chang'e-4. You can see the probe included a descender, a lander, and an orbiter, and its major task is to take a sample from the surface of the moon. And for sample collection, we have two ways. One is we use a drill to drill into the subsurface, and another is to sample from the surface of the moon. And after that, the ascender will lift off from the lander, and then it will dock in the lunar orbit. Then it return to our Earth. I will introduce the current state. Okay, this is the launch vehicle, and here is the picture to show this compared with the most heavy launch vehicle with other countries, including Russia, United States. And here, Long March 5 is number 4 here. And for the lunar transfer orbiter, this launch vehicle is about 8.2 tons. This is also the launch ability for Chang'e-5. For the Chang'e-5 mission, actually, we initially planned to launch in late 2017, but due to the launch vehicle problem and delayed the 3 years. That means the trial was delayed 2 times because of the rocket issue in 2017 and 2019. Okay. And here is some pictures show you the launch time. Here, I kind of show the view, the coverage. Here is also a live stream in CGTN. Many people viewed it through the internet. And the exact launch time is the 4:30 a.m. November 24th, 2020 in the Hainan Island. And below this panel show you the how it works. And you can see in the middle, the night in Hainan Island is very cloudy. So I was there. I was standing in the coast, and you can see once the launch vehicle blast and the very bright in the surface of the sea, and very soon it entered the cloud, and we can't see anything. The cloud is very thick. So here you can see from the ground to the atmosphere quickly disappeared. Here is a very short video show you how Chang'se-5 landed. It was taken by a descender camera. It's a real one. It's not a simulation. Yeah, sorry, what's the problem? Okay. Problem. Okay. Let me just move to the final stage. Okay, this is the touchdown. It has touchdown. It had the date of December 1st, 11. Sorry. And actually, this is another pinpoint landing as Chang'se-4. And the position here, at least here, is 43.1 north and 51.8 west. In the right, you can see where is the landing site. Here is some image immediately published by our international colleagues. They collect some previous figures and plot the landing point here. And you can see here is located in the northern Oceanus Perseilum, very close to longest lunar reel. We call it the Rimbula sharp. And here is, you can see the scale bar here is, the first one is 10 kilometers, and the second 2.5, third 500 meters, and the last is 100 meters. You can see here, the last one is the real landing point by Chang'se-5. And then later, the LRO also captured the landing site, and you can find the lander just located in the center of the square in the right, the image. And here is the panoramic camera aboard the lander, and it image the landing site. This work was prepared for sampling, and you can see the surface is generally fine grain, rich in fine grain materials, but there are still some large rock boulders, and the size here, the two big ones is around half meters in diameter, and even bigger. You can see also from the lander's footpad, is the rock is not so loose. It means it's a little bit tough and rich in big grains. From the view, you can also see many rocks, not outcrops, but they are large boulders. Here I want to show you how they do sampling work. The first image show you is a simulation, and we have two ways. One is for drilling, and another is from the scope, so sample from the surface. And then the left, upper right is the monitor camera captured the image. I want to just can show you how it works. And so you can see it's a geo and moment of stop, and then geo, and keep going, and then In the right, the below one is a simulation, and the red line shows you the how the sample. The sample was put in a soft bag, and then it was poured to surround this sample capsule in the middle, lower metal panel. You can see the upper part within the tank. There's a soft sample bag within that. After sampling, surface drilling sampling, and this part will remove, and you can see the left in the below. You can see there is no this kind of sample capture, and it has been moved away and ready for a surface sample. The surface sample will put just in the middle of this container. This one I show you how we do surface sampling by dig and scope. This is the real-time show and also simulation, and then the monitor camera in the right. You can see how it works. Because it's a robotic one, it works very slow, but very successful. You can see if you look at the very detail, you can see the materials, the lunar soil or rock glass has been taken and put in the container. I want to show you again this just to focus on the right side, the container. Sorry. So the sample was taken and it was transferred to the container. And look here, the sample was dropped down from the scope. So this is a monitor camera. We can confirm we have really collect samples from the surface. Okay, here is the surface sampling, and in the above panel show you the before scope, and we can see there is large light color rock photos, and the left is just the original one, and the right you can see there is some dark shade here. This means this area has been sampled, and below the same, and the left is before sampling, and the right is after sampling. So sampling we have collected three sites. There, and totally about 12 times scoping. The surface sample is from these three points. After the successful sampling, the ascender was lifted off in the later evening. It's 11 p.m. December 3. And everyone has to know, I think this one has been docked with the. Here is the lifting time. This was taken by the lander monitor camera. You can see the ascender was successfully lifted off. And also the docking and the sample transfer is very successful. The docking time was 5:42 a.m. Just yesterday morning, and the transfer was successful at half an hour later. Is 6:12 a.m. Also yesterday. So this is first time for China's space exploration to do this kind of job, and it's very successful. Here is some images issued by the China Space Agency. And hereafter, the spacecraft will take sample return to Earth. The time we expect it to return to Inner Mongolia, the Xiao will be the early morning of December 17. Is about 10 days late we can get the sample. And here is some technology has been tested. The right panel show you this is a Chang'se-5 test mission. This test mission is to test how we can do retrain and re-enter the Earth's atmosphere at a very high velocity. And this kind of technology has been tested, so we are very confident that this is the last stage will be very successful. Okay, so I want to just review China's lunar program. Here is show you the Chang program from Chang 1 to Chang 6. It includes 6 missions and divided through 3 phases. The first is orbiting. It includes Chang 1 and the Chang 2. For landing, the Chang 3 and the Chang 4. For summer return is Chang 5 and Chang 6. So Chang 5 is the last phase of Chang mission, and the Chang 6 is a backup of Chang 5, and we will plan to the analyzing also a summer return mission, maybe 2023 or some. It has been confirmed because we will re-evaluate the value of the mission. Okay. Hereafter, I want to introduce where we have gone and what the kind of type of the rocks or regoliths we have sampled from the surface of the moon, and why we choose this site for sampling. Here you can see the previous landing site, including Apollo and Lunar, and Chinese Chang 1, Chang 3, and so on. And finally, we choose the Mons Romic region for landing. It is located in the northern oceanus perihelion. This pre-selected area is pretty large. It's you can see here is the altitude and longitude, and it covers 55,000 square kilometers. This region was selected is mostly because here we found some young volcanic rocks. From the image, it was published in 2011 by Harry Hensing. He did a great job to do critical counting to calculate the age of each volcanic unit. You can see the volcanic history lasted from about 4 billion years to about 1.2 billion years, and it's a pretty long time. But when we look at the Apollo and the lunar summer sites, you will find that they are mostly located within the old terrains, older than 3 billion years ago. And at that time, scientists think the lunar volcanism has been stopped since 3 billion years. And also some people said that the moon was dead since then. But remote sensing data analysis suggests some places may be younger, and they should have a longer volcanic history. But this kind of hypothesis or interpretation have not been confirmed by sample. So scientists, we need a sample to test this kind of analysis. So here let's look at the Romic region. The Romic, the most preliminary, the topographic feature is Romic Mons. It's at the center, but close to the south boundary, we call Romic Sea here. And actually, the southern side is targeted at the Mons, but the eastern male basalt is dark. You can see very dark area, and the star show you the landing site. This area is rich in volcanic complex materials. It includes volcanic complex, that's the monzon rock, and the volcanic plains, including the old and young male basalt, and also here is volcanic domes and volcanic channels in the east part, very close to the landing site. So here is the ideal place to study lunar volcanism, and we also published some papers to discuss this. These pictures show you the geological diversity of the Rimbula region. By using the spectral data, we analyze the composition difference. You can see the titanium ion, they are quite different, but this cannot see from the image. So based on this analysis and correct counting, we divided this year as several geological units we could see SFD. It means crater size frequency distribution. And from the low panel, the left one, you can see the ages were marked here. In the east part is about 1.2 billion years. It's much younger Apollo sample, the age we get. So before it was landed, we proposed to land in the east part, and also some people also suggest, and finally the mission group accepted this suggestion and landed in the east part. The geological history tells us here has a very long geological history. Here is a long list about the geological activity. I don't want to go very detailed, but you can see here geologically from time, you can see there includes two major geological time. One is the Imbrian. It includes some volcanic male materials and some dome materials, and last to Eratosthenian. It's very young. As I said before, the volcanic rocks is young as 1.2 billion years old with EM4. It's the most youngest volcanic unit. Here is the list of the scientific opportunities from the young male basalt. This paper has been accepted by EPSL. It's impressed on, and generally it includes this part. One is the volcanism and chronology. As I said before, volcanism history is very important for us to understand the life of the moon. And for chronology, if this kind of age can be confirmed by our laboratory study, like isotope dating, and we can calibrate the chronology curve used by international planetary science community. Whatever this is, how consistent or inconsistent, it will play a great role in that. And also we can study the rocks for his petrology, geochemistry, and mineralogy to understand the petrogenesis. We can understand where this is the magma come from, why it was melted, what's the heat source. Many things we can do. And we can also study the regional setting, for example, the thorium content, because here the landing site is is within the PKT terrain. I will say a little bit more later. And also, if this age, the EM4 or the youngest volcano has been confirmed, and it will shed light on understanding the thermal evolution of the moon, and also for its dynamic history. Again, the Regulus is another hot point by scientists because we don't know really know the regular growth rate. Apollo landing site, they are very old because it means the regulus has been formed or modified for more than 3 billion years. But the Chang'se-5 site is younger. It may be just 1.2 billion years or 1.5 billion years. And the regulus property and its special Western history is different. And we can check, we can compare this materials with the previously published data, and we can know more about the spatial weathering and regulus formation rate. So first, for the lunar volcanic history, I have shown here the hatching study suggests that on the surface of the moon there is some places have very young, very recent volcanism lasted to 1 billion years. Okay, here is that. But look at the low panel. Here is the Apollo samples data. You can see all of them are older than 3.1 billion years. And the youngest rock dating data is from two lunar meteorites, NWA-773 and NWA-232. Here is a little bit younger than the Apollo samples. Just still, they are older than 2.9 billion years. So there is no young basalt that has been sampled, whatever from the Apollo sample or the lunar meteorite. So also some people suggest that the lunar volcanism has been lasted to 1 billion years, whatever the low titanium male basalt or high titanium basalt, but have not dated or confirmed by lunar sample. So this is very important to do this kind of thing to understand the lunar volcanic history from the Chang'se-5 sample. Another is lunar impact history. Some people may be familiar with this kind of method. We call it a chronology method. It is widely accepted and applied for the planetary science community. For the moon, here you can see this curve, and many points they are plotted in this figure. There is Apollo 11 to Apollo 17, and this part from the age older than 3 billion years is well calibrated. And you can see from 3 billion to 1 billion, there is no marks, no data in this curve. So we don't really know this curve is correct or not. And so for the poorly concentrated parts or time, the duration, we need more samples. And the Chang'se-5 sample, based on the interpretation of the crater counting, so it must be here, and we can mark we can point some people we call it as a golden mark here, and can calibrate this kind of chronological. This is very useful not only for the moon to date the moon, but also for other airless bodies, and it's very important, I think. Another thing is for the lunar dynamo. From the Apollo samples, some scientists have studied it and find there is some time also from 3 billion to 1 billion. There is polyconcentrated by the lunar dynamo. Some samples, for example, the Apollo 15, there is suggested still some how to say, the intensity of the magnetism. So don't know that. We don't know from 3 to 1 billion years what happened there. I'm not a geophysicist, but I think this. Some geophysicists are very concerned about this kind of sample. They want to study the magnetic intensity and to understand the lunar dynamo history. For the geochemist and the geologist, we want to the deep mantle properties and make some. There may be also some information can be used to understand the magma ocean model. Here is the field cartoon show you with the cooling of the magma ocean, the lunar crust is getting thicker and thick, and at the same time, the magma from the lunar mantle is getting deeper and deep. It means the youngest volcano or lava should be generated from the deep mantle. So if we have a good age and we also have the geochemistry, we can know what's the component in the deep lunar mantle. And this can also be used to understand the magma ocean the overturn mission. And because this basalt, as we started, there is high titanium basalt. And the high titanium, generally, people propose that they are partial melting product by the immunite-rich material. And then we can use this the chemistry data and the isotope data to further concentrate the magma ocean overturn model. Last, I want to say is the PKT terrain. PKT terrain is very special. This means this area, they are rich in potassium, rare earth element, and phosphorus element, and located. They covered the most of the near side of the moon, and the Chang'se-5 was just located within the PKT terrain. But we don't really know what kind of mechanism to produce this terrain. Why they are rich in, for example, thorium. There are two models has been proposed. One is by Brad Jolley. He think this kind of thing was produced by we call it inherent hypothesis. But another people, they think this may be a extraneous orange hypothesis. This is by mixing. Okay, I don't want to go very detailed, but this is a totally different model to explain this kind of PKT formation mechanism. Okay, yeah, I just highlight some importance of the lunar sample from maybe from the Chang'se-5. These years, our group has did some work on the lunar landing site. There is a short list published by my students. If you have interest, you can check this and. Okay, last, I want to use this opportunity to introduce RA, the journal. Actually, this journal it is a monthly astronomy journal by the National Astronomy Observatory Center in Beijing and the China Astronomical Society. It accepts research papers, invited reviews, latest editors' recommendations, and the editor-in-chief, the current is Professor Han Zhenwen and Gao Liang. Also, Professor Yip, he is the co-executive editor, and he did lots of work for this journal. I would like, as a a member of editor board, I would like invite people to submit your study to this journal, and this journal's impact factor is growing very fast, and it's a well-known international journal. Okay, thank you.